Hello and welcome to Mr. Franklin Explains Some Math. I am going to try to explain what's going on in this Google Doc. So here are two problems from the text from the chapter we're working on with quadratic equations. I am going to solve the first of these two problems. The second one is up to you to try. Then you can turn it in for some feedback. The opening of the cannon pictured at the left is 16 feet above the ground. The daredevil, who is shot out of the cannon, reaches a maximum height of 55 feet after about 1.56 seconds and hits a net that is 9.5 feet off the ground after 3.25 seconds. Use this information to answer the following questions. So what we need to do is use some algebra skills and the equation for anything that is thrown or shot, or for example shot out of a cannon. Here is that equation. We're going to write a rule that relates the daredevil's height above ground, h, at a time t seconds after the cannon is fired. In this equation you can see that t is the variable that we have inside our equation, and h is what we're looking for. So if this was an x and y equation, t would be x and h would be y. So what I'm going to try to do is make this equation here. I'm going to do a little copying and pasting here. But I'm going to put in some of the information that I know. So looking at the information that we're given, we can see that when time is 1.56 seconds, then the height is 55 feet. And we know that the opening of the cannon is 16 feet above the ground. So let's put in some of that information. So when time is 1.56, so that's when the time, I'm going to replace all these t's with 1.56 seconds. And I know that the initial height, which is h sub 0, is 16 feet. Hopefully you can see that when the daredevil flies through the air, no matter what the time is, the height that he started from, or she, stays the same. But as time changes from 0 seconds to 1.5 seconds and above, then the height is going to change. And this says that at 1.56 seconds, the height is 55 feet. So now we've got an equation that we can work with. I'm using a calculator on the side to do some of my calculations instead of like an on-screen one, but I think you'll be able to follow along. What I've got to do is simplify this equation here. I'm going to start by doing what's in parentheses. And here in the parentheses, well, there's nothing else I can do there. Or parentheses over here, well, there's nothing else I can do here. But there is an exponent, so I'll do that next. So my equation becomes 55 equals 16 plus v sub 0, pronounced v naught sometimes. And that's still times 1.56. We'll come back to that yet soon. But this, the 1.56 squared, on my handy dandy calculator, since this has started with 2 decimal places, I'm going to round off to 2 decimal places. And 1.56 squared becomes 2.43. So I've done my exponents. Let's do some multiplication. That's the next thing in PEMDAS. So I've got a multiplication here of negative 16 times 2.43. Doing that on my calculator, I'm going to change that to 38.94. There's a multiplication over here, but I'm going to leave that for now because I don't really know what v is yet. That's what I'm trying to find. this multiplication here is going to get undone in one of my last steps. Once again, I'm just going to copy and paste this down here. And let's look at some numbers that we can combine. We've done multiplication. I don't see any divisions. So how about some additions and subtractions? This negative 38.94, that's a constant. And this 16 is a constant. And then lastly, there's a constant on the other side. So let's combine some like terms. On my calculator, I'm doing 16 minus 38.94, and that's negative 22.94. So I've now combined the 16 and the 38.94 with subtraction, and I've got negative 22.94. The next step I see, I'm trying to get down to the point where I've got v sub 0 by itself. That's really what I'm trying to solve for here. But hopefully you can see that I'm not there yet. Some formatting issues, but I'm getting there. Okay, so the next thing I'm going to do to get rid of subtract 22.94, of course, I'm going to add it to both sides. So on this side, I'm going to do plus 22.94. Point. And over here, I'm going to do plus 22.94. And this positive 22.94 and this negative are going to cancel each other out. But I'm going to add 55 to the 22.94 on this side. And what I end up with, let me draw my line so you can see that I'm going to the next step. What I'm going to end up with here is 77.94 equals v sub 0 still times 1.56, but I haven't dealt with that yet. But I'm about to. In this next line, what I want to do is now some division. I need to get rid of the 1.56 off of this, so it's just v sub 0 by itself. So of course I'm going to divide this side by 1.56. And then anything that I do to one side, I have to do to the other side. So now I've divided both sides by 1.56. And I'll need my calculator to figure out what that gives me. 77.94 divided by 1.56. And that is 49.96. And that equals v sub 0. Hopefully you can see that it's not too much of a stretch that I'm just going to switch this around. But I'm going to round off this a little bit, because this is going to be 49.96. That's really close to 50. And the initial velocity is 50 feet per second. So, with all that information, I now finally can make the full rule, because I know all of the numbers that go into it. I know that a rule that says h of t is going to have the initial height of 16 and the initial velocity of 50, which gets multiplied by t. And since we're still on Earth, t squared. So that right there, I'll put that in green. Nope. That's not what I wanted. Never mind. I won't put it in green. That right there, though, that is an equation that relates height, h, to time, t, for any second that I pick in this situation. I totally could have used the fact that at 3.25 seconds, the Daredevil lands, which is 9.5 feet off the ground, and I would have come up with the same numbers. I leave that as an exercise for the student. The answer to this question, what upward velocity is the Daredevil shot from the cannon, that's what I just found here. I guess I jumped the gun a little bit and did everything in one step. What this question is asking for is what's the velocity? And it's 50 feet per second. Lastly, if for some unfortunate reason the net slipped, when would the Daredevil hit the ground? We know that if the height is 9.5, then the time must be 3.5 from what was given in 3.25 from what was given in this problem. So this would be 16 plus 50t minus, where the t is 3.25, minus 16 times 3.25 squared. We already know that that works in the equation. The question is, what would be the time t, if instead of at 9.5 feet, they landed at 0? Well, this is a little bit harder to figure out, and I don't think we have the algebra skills yet to solve this for t. So what we need is a numerical solution, or how about a graph? Let's go over to desmos.com. And I'm going to put in the equation that I have. I have h equals 16 plus 50t minus 16t squared. In order to put in the squared in Desmos, I used Shift 6, the caret. And hopefully what you can see over here is that I've got a parabola. Well, I can't see the top of it yet. I could zoom out, but then it's too skinny. So I'm going to, I happen to know that the Daredevil is probably not in the air for more than 5 seconds. So I'm going to make my x-axis go from -5 to +5. And I think we can probably get a better look at this. There we go. This is a graph that is a representation of what's going on. You can see that when time is 0, it's 16. The height is 16. We knew that at about, look at that, 1.56 seconds, the Daredevil is at 55 feet. And if we go over here to where x is 9.5, do you remember that the height is 9.5, that the time is 3 1/4. Almost get there. There we go. That is a solution to this equation. It's right where we would expect it to be. And the last answer to this is that at 3.4 seconds, 3.418 seconds, the Daredevil would hit the ground if this person missed the net, which would be very sad and unfortunate. Let me go back to the Google Doc. Actually, I'm going to put this right into the Google Doc so you can see what it was. And here is the graph that we use to solve this problem. And the answer to the question is, when is the height, what time gives me a height of 0? That's the question we're asking here. And the answer is when t equals 3.42 approximately. Hopefully you can see that I've rounded off there. And that is all the answers and how you would find the answers, sometimes using algebra when we can, and sometimes using a graphical solution when we can. There's also ways that we could use a table. That's a lesson for another day. In this problem, I've now written out the answers to problem number 3, the first one, and shown you the steps in this video. So hopefully that's enough to help you complete problem number 2 about Katie, the goalie at Riverside High. The method is going to be similar, but not exactly the same, because this is a uniquely different problem. But I really want you to give it a try. You can rely on the graph through Desmos. You can rely on your algebra skills. They're both good ways to do this. Thank you very much, and I'll see you next time.